students, we have seen two different types of conductors and the shape of it, and accordingly how the magnetic field lines get affected. So now let us discuss the third part of the type of conductors according to which the magnetic field lines are generated, and that is solenoid. So let me be clear first of all, what is solenoid? Okay, so solenoid is just kind of coil containing many circular turns. Like earlier we have just seen the single loop, single kind of circle, and according to which we have seen that there is a magnetic field lines that is making a circular magnetic field lines here, and from the center it is straight. Okay, if we are like for a single wire, for a long single wire, if we are making a multiple turns like this, multiple turns I am making here, so this is known as solenoid now. Okay, that is making like a cylindrical shape. As you can see here, अगर हम एक ही चीज को बार बार एक ही ऐसे circle बना दें, so and join it like this, so it will treat it as a cylindrical shape only. Okay, so this is how the solenoids look alike, and here the magnetic field lines in the solenoid are in the same manner like this. Okay, so now the thing that is need to be done, if we pass a current through this circuit, like here, from here the current is going to flow, from here it is going to be down, again up, again here down, again up, like this, क्योंकि circular है, so it will going to be down up again like this. Okay, so this will be affecting the magnetic field here, and for a particular point again you can use the right hand thumb rule to find the direction of magnetic field. So here, like in this case, the current is flowing from here and it is going here and like this, and going to be down. Okay, now let me draw a multiple loops for you. Like 3 loops I am making just to show you how it is going to work. Okay, we have taken the current in this direction. So current is going to be here and now down, and then from the back side again up, then here, then down, then up, then here, then down, then up, and now the down automatically. Okay, so for this direction, for this particular point, if I want to know what is the magnetic field here, so I will keep my thumb here like this in the direction of the current, and accordingly will get the magnetic field lines like the fingers are showing it. Okay, so now the current, the magnetic field lines are in this way. Here at this point, in this way, all the points are showing in this way, and if we are clumping it all, because they all are very close to each other, because I have just made to clear you people, see, so I have made it a little far, but actually solenoid is not having a certain gap, like this is gap, this is not allowed in solenoid, these will stick to each other. So if they are stick to each other, it is just like a cylindrical thing like this, and that I have told you. Okay, so accordingly if we are going to connect all these points, it will show a certain single loop like this. Okay, so what kind of loop it will be? It will be like this, a current will flow here on magnetic field lines is going to be here like this and coming back to this direction like this. Okay, so this is the diagram for magnetic field line, and it is showing you how the magnetic field lines are coming and making into the solenoid. Okay, so solenoid here, as we have seen that this is like a cylindrical shape, so we can say it is like a bar magnet only. How? See here, solenoid and a bar magnet. So in the both cases, magnetic field lines, as you can see, the direction of it is from the north to south, and in this one also north to south. Okay, so from both the cases, as you can predict where the current magnetic field lines will generate and where it going to be end. Okay, so it is generating from the north and going towards the south, going from the north and coming towards the south. Okay, so this is the best idea that we can relate it to the bar magnet and will give us the idea from where we will get the north pole and the south pole. One more thing, as I can see from here, that inside the solenoid, because you know in a single loop we are having a straight line magnetic field line. Okay, when we were talking about the this circular loop, I have told you that from the center the magnetic field lines are in a straight manner. So when we are clumping all these loops together and we are combining the straight magnetic field lines of all the loops together, so we can say that here also the magnetic field lines for all the loops combinedly in a solenoid are in a straight line. So this will gives you the idea that magnetic field lines, like in a bar magnet, emerges from one end, merges into the another end, and also like a bar magnet, like here it is going inside the bar magnet from south to north. In the same manner, field lines go parallel straight lines inside the solenoid also. Okay, so these are the uniform lines inside the solenoid too. So whenever you are asked a question like what are the magnetic field lines direction and inside the solenoid, so you can say the answer like this: the inside way of the magnetic field line inside the solenoid will be the parallel straight lines. Inside the solenoid it is the parallel lines. So you can see from the diagram also the parallel lines are going inside the solenoid. Okay, now north pole and the south pole, for this I have a little trick for you guys so that you can find where is the north and the south pole also. Like current is drawing from here and it will go in this wire and going like this. Okay, and if from my side, if we see it like this, that the current is like this. Okay, so current is flowing from my side. From your side you can take, from my side I am taking it like this, that my fingers are going with the current direction right now. Okay, like this, and this thumb now representing where is the north pole. Okay, so according to the current's direction, now we can take right hand rule again, but in this condition we are vice versa. We are going to be vice versa, the current and the magnetic field direction. Now this is the direction of the current that is flowing into the solenoid. So according from my side, it is going to be like this. The part of the solenoid whichever I am looking from my side, it is from here, like this, in this direction. So I am putting my fingers like this, and now this thumb is representing the north pole. So we can say that here we are having a north pole, or here if it is a north pole it will be the south pole. So main things that we have seen here is the north and the south pole. Accordingly we generated the magnetic field lines, and it is similar to the bar magnet, and inside like the bar magnet the magnetic field lines are parallel to each other. It's in the same manner it has been done in the solenoid. So it means that magnetic field lines is same at all points inside the solenoid.